are going to see magnetic field due to a straight conductor carrying current. We can apply Biot-Savart law to find the magnetic field here because of the current passing through this conductor. Here there is a current passing in this direction. Our aim is to find the magnetic field here due to this straight conductor. To apply the Biot-Savart law, you consider a small current element of length dl. Then this point P is at a distance a from the wire. This current element is at a distance r from this point. The distance between the current element and point is r, and let this angle be theta. This angle, let it be theta. Then join P to the end of the wire. This angle is phi 2. This angle is phi 1. First we will get the magnetic field here due to this current element. Then we will use integration to find the magnetic field here due to this wire. Magnetic field here due to this current element can be written using Biot-Savart law. dB vector, magnetic field here because of the small current element is dB vector. Then according to Biot-Savart law, mu 0 divided by 4 pi I dl sine theta by r square. Then here magnetic field is into the board. Here this is the direction of dl vector, this is the r vector. Then magnetic field will be perpendicular to both dl and r vector. So that is this shown by this n cap. So n cap is a unit vector perpendicular to both dl vector and dl. This is the dl vector and this r vector. Now for integration we have to replace this dl and r. We have to change this dl and r. So for that we can use trigonometry. Here theta. So this angle will be pi minus theta. Pi minus theta. So tan pi minus theta, in this is pi minus theta. So tan pi minus theta is opposite side by adjacent side. So you can write a by l. Then here we can use trigonometry. Tan pi minus theta. So this can be written as tan 2 times pi by 2 minus theta. So if it is an even multiple of pi by 2, tan can be written as tan theta. Then tan pi minus theta is the angle in this pi minus theta. Pi minus theta is an angle in the second quadrant. Second quadrant sine and its reciprocal cosecant theta will be positive. Tan theta is negative. So tan pi minus theta is minus tan theta. Using trigonometry you can write like this. So it is a by equal to a by l. After rearranging you can write for l from this. L is equal to a divided by tan theta. 1 by tan theta is cot theta. Then take this negative sign to the other side. So after rearranging L is equal to minus a cot theta. Then our aim is to get to dl. So you differentiate this dl by d theta. dl by d theta a then differential coefficient of cot theta is minus cosecant square theta. So already one negative sign is there, so it will become positive. So after the differentiation you will get a dl by d theta from dl by d theta is a cosecant square theta. Then after rearranging this you can write an expression for this dl. dl is equal to a cosecant square theta d theta. Then for replacing this r, in this triangle you apply sine pi minus theta. Sine pi minus theta, this angle, this pi minus theta. Then sine pi minus theta is opposite side by hypotenuse. So you can write it as a by r. So here sine pi can be written as 2 times pi by 2. When it is a multiple of even multiple of pi by 2, sine will be sine pi minus theta can be written as sine theta. Then the second quadrant sign is positive. So sine pi minus theta can be written as sine theta is equal to a by r. Our aim is to get an expression for r. So after rearranging this, r is equal to a divided by sine theta, because 1 by sine theta is cosecant theta. So from this we can write r is equal to a cosecant theta. So now we can replace this dl and r by these before integration. For this dl, you can substitute a cosecant square theta d theta. Then for this r, a cosecant theta, its square. Then there's a magnetic field here due to the small current element. For this wire, we have to integrate this. Then this theta is the variable. Here, theta is changing from phi 1 to phi 2. So the limits of integration is phi 1 and phi 2. Then after integration, total magnetic field, that is this dB vector will become B. It will become B. So now integral of sine theta is minus cos theta. Then lower limit phi 1, upper limit phi 2. Then substitute minus upper limit phi 2. So cos phi 2, upper limit minus lower limit. Lower limit is phi 1. So minus cos phi 1, minus into minus plus. So total magnetic field will be mu 0 I by 4 pi a cos phi 1 minus cos phi 2. When this conductor is infinitely long, this phi 1 will become 0 and phi 2 will become pi. So you can substitute for this phi 1, you can substitute 0, and for this phi 2, you can substitute pi. Then cos 0 is 1 minus cos pi is minus 1, minus into minus plus. So 1 plus 1, 2. Then this 4 and 2 can be you can write 2. After simplification, you can write 2. So B vector is a vector quantity, so we have to write n cap, B vector, so it's n cap. Now here, so this is the magnetic induction here because of an infinitely long straight conductor carrying current. So magnetic field depends on the current and the distance. Then this n cap shows magnetic field is directed into the board. So here current is in the upward direction. Then as per the right hand thumb rule, field is directed into the board. So this n cap shows the direction of the magnetic field. Thank you for watching.